Ever tried to imagine building a skyscraper? And every time you need to add another floor, you gotta like demolish the whole thing and start over.
Seems pretty inefficient.
Yeah, it's kind of what it's like trying to scale up these huge AI models,
Mhm.
especially transformers.
Yeah, that's definitely a challenge that the AI community has been wrestling with.
So today we're going to dive into a paper that thinks it might have a solution. It's called Our Method, Rethinking Transformer Scaling with Tokenized Model Parameters.
Yeah, it's a pretty radical approach to building and scaling these models.
Okay, so to set the stage a little bit, we know transformers are amazing, right? I mean, they're dominating pretty much every corner of AI.
Yeah, and they keep getting more powerful, it seems like, every day.
But here's the thing. The bigger they get, the more computationally expensive they become.
Absolutely. It's a problem of scale.
Right. And it all comes down to how these traditional transformers are built. They rely on something called linear projections, which basically control how data flows through the model.
Yeah.
But the problem is, if you want to change the model's architecture even a little bit,
You often have to retrain the entire model from scratch.
exactly. And when we're talking about models with billions or even trillions of parameters.
That retraining can be a complete nightmare, logistically and computationally.
So that brings us to the big question, how does our method try to solve this? Well, they introduced this concept called token parameter attention, or patention.
And the core idea is to treat the model parameters themselves as tokens.
Wait, so the model parameters are tokens. I'm trying to wrap my head around that.
It's like giving the model the ability to kind of dynamically adjust its own structure based on what it's learning.
So instead of rebuilding the entire skyscraper, we're kind of just like swapping out pipes here and there.
That's a good analogy.
Okay, so how does that actually work? How do you treat a parameter as a token?
So in a traditional transformer, the input tokens interact with each other through the attention mechanism, right? But they also interact with the model parameters through those fixed lineal projections.
And those fixed projections are the bottleneck.
Right. But with our method, the input tokens can directly attend to the parameter tokens.
So the parameters are like keys and values.
Exactly. It's like the model is deciding which parameters are important on the fly.
That's wild. And they actually show that this works.
They did. They scaled our method from 124 million to 1.4 billion parameters, and it matched the performance of models that were trained from scratch, but it used way less compute.
So it's not just about making these models bigger, it's about making them smarter.
Exactly. And more efficient.
This feels like it has huge implications for AI research.
Absolutely. Think about being able to develop much more powerful AI systems without needing those massive supercomputers.
It could democratize AI research in a way we've never seen before.
It's exciting to think about.
Okay, so let's get a little deeper into the weeds here. How does this potential layer actually work? What's the magic behind it?
So, as I said before, in a traditional transformer, the input tokens interact with each other through the attention mechanism. They also interact with the model's parameters, but through those fixed linear projections. And we already talked about how those fixed projections are kind of the bottleneck.
Right, they're like the limiting factor.
Exactly. But in our method, the input tokens, well, they can directly attend to the parameter tokens, which are acting as keys and values. So it's like giving the model the ability to decide which parameters are most important for a given task.
Okay, I think I'm following. But how does adding more parameter tokens actually make the model bigger? I mean, what does that even mean in a practical sense?
Well, each parameter is like a little piece of knowledge or a capability within the model. Think of it like adding more neurons to a brain.
Okay, so the more neurons, the more complex the thoughts or actions the brain can handle. So more parameters means more knowledge and more capabilities.
You got it. Our method basically lets the model expand its knowledge and capabilities without needing a complete overhaul.
So this feels like a huge paradigm shift in how we think about building AI. But, treating parameters as tokens sounds great in theory, but isn't it just shifting the complexity somewhere else? Is it really more efficient in the long run?
That's a great question and something researchers are looking into. Our method shows some really promising results, but there are still questions about the long-term implications, like how does this increased flexibility affect the model's stability or its robustness? Those are things we need to explore further.
So it's like we've opened up this incredible new toolbox, but we're still figuring out how to use all the tools effectively.
I like that analogy.
So our method might not be a silver bullet, but it's a big step forward. Now that we understand the problem and the proposed solution, what are some real-world applications where this could really shine?
Well, one area that jumps out is large language models. These things are already pushing the limits of computational resources, so any improvement in efficiency is huge. But I think it goes beyond that. We could see things like more powerful computer vision systems, more sophisticated robotics, even advances in scientific discovery. The
Right.
possibilities are really vast.
Yeah, it really is a fascinating time to be in the AI field. Feels like we're on the verge of something big.
Okay, so we've talked about the potential for research and development, but like, what about everyday life? How could this impact, regular people?
Well, think about a world where AI models are not just powerful, but also incredibly personalized.
Personalized AI.
Yeah. Like imagine education, for example.
Yeah.
With our method, we could develop models that personalize language learning, adapt to each student's progress and learning style.
That would be huge for students who struggle with traditional methods.
Right. It's like having a personal tutor available 24/7. That's just one example. Think about healthcare, finance, transportation.
Yeah.
The possibilities are endless. So our method could lead to AI that's more intuitive, more responsive, and more tailored to our individual needs.
Hmm.
Sounds pretty utopian. But like with any powerful technology, there are potential downsides too, right?
Of course. We have to be careful.
I mean, what could go wrong? More powerful AI, more problems. I know you're not a fortune teller, but what are some things we should be thinking about?
Well, our method itself doesn't introduce any new ethical concerns, but it does amplify existing ones.
Okay, so what do you mean?
For example, we need to be even more careful about the data we use to train these models.
Hmm.
A bigger model doesn't automatically mean a less biased model.
Right. Garbage in, garbage out.
Exactly. We need to make sure the data is diverse, representative, and free from harmful biases. And we also need to think about the potential impact on jobs and the economy as these systems become more capable of automating complex tasks.
So it's not just about the technology itself, it's about how we use it.
Exactly. We need to be proactive, not reactive. Establish ethical guidelines, develop robust testing procedures, and foster a culture of responsibility within the AI community.
It sounds like we're going to need a whole new skill set to navigate this AI-powered future. Not just technical skills, but also ethical, social, and even philosophical skills.
Absolutely. We're going to need people who can build these systems and also understand their implications, anticipate potential risks, and make sure they're aligned with our values.
Speaking of values, that brings up an interesting question. Our method is all about creating AI models that are more flexible and adaptable.
Hmm.
But does that flexibility actually make them more intelligent?
That's a good question. What does it actually mean to be intelligent? Is it just about processing information quickly and accurately, or is there something more to it?
It's a question philosophers have been debating for centuries, and now we're asking it about machines.
I think our method challenges us to rethink our assumptions about intelligence. If we can create machines that learn and adapt like humans, what does that say about us?
It's a humbling thought. Maybe it's an opportunity to learn more about ourselves and explore the boundaries of intelligence, to create a future where humans and machines can coexist and collaborate.
I like that. Instead of fearing AI, let's embrace the possibilities, use it to solve problems, and create a brighter future for everyone.
So now that we explored the potential benefits and challenges, what do you see as the key research questions that need to be addressed in the coming years? What are we still trying to figure out?
Well, one area that I'm particularly interested in is developing new evaluation metrics for these adaptable AI systems. Traditional metrics focus on static performance benchmarks, but we need new ways to assess how well these models can adapt to new situations, learn from limited data, and generalize to new tasks.
So we need new tools to measure intelligence, not just for machines, but for ourselves as well.
Exactly. Another important area is safety and robustness. As models become more complex and dynamic, it's harder to guarantee that they'll always behave as intended.
All right, we don't want to create AI that's so flexible that it becomes unpredictable or dangerous.
Exactly. We need to develop rigorous testing procedures, build in safeguards, and do more research on AI alignment to keep these systems under control.
So as these AI systems become more sophisticated and integrated into our lives, how do we ensure that they're making decisions that are fair, unbiased, and understandable? How do we make sure we can trust them?
That's where transparency and explainability come in. We need to be able to understand why these models make the decisions they do. It's an area called explainable AI or XAI.
So it's like we need a translator for AI,
Yeah.
right? Something that can bridge the gap between how these models work and how we think.
Yeah. We need to make these systems more transparent and interpretable so that we can understand their limitations and identify potential risks.
This has been a really insightful conversation. Our method is a big step forward, but it definitely raises some profound questions about intelligence, the future of work, and the ethics of AI.
It has. It's been a pleasure discussing these topics with you.
Before we wrap up, is there one key takeaway you'd like listeners to remember? Something that'll stick with them?
I think the most important thing to remember is that the future of AI is not set in stone. It's something we're creating right now, with every choice we make. So let's be mindful of those choices. Let's develop AI that benefits everyone and work together to create a brighter future.
That's a great message. Thank you for joining me on this deep dive into our method. It's easy to get lost in the weeds when you're talking about a paper like this, all the technical details, but I think it's important to zoom out and think about the big picture.
Oh, absolutely.
Like, what does this research tell us about the future of AI? What are the possibilities and maybe even the risks of this technology?
Well, for me, one of the things that really stands out about our method is just how audacious it is. Like rethinking the fundamental building blocks of these transformer models.
Yeah, it's like they're saying, hey, we don't have to be limited by the way things have always been done.
Yeah. Right. Like, let's question the assumptions, break down the barriers, and imagine entirely new ways of building these powerful systems.
It's that spirit of innovation that really drives progress in any field.
Especially one that's evolving as quickly as AI.
It's exciting to see researchers pushing the boundaries like this, coming up with these groundbreaking ideas.
For sure.
But I think it's important to remember that innovation doesn't happen in a vacuum.
It's true.
It's shaped by the values, the priorities, the cultural context of the people who are doing the innovating.
Right.
And that's why it's so important to have diverse voices and perspectives represented in the AI research community.
Couldn't agree more.
If we want AI that's truly beneficial for all of humanity, we need to make sure it's developed by teams that reflect that diversity.
Absolutely. We need people from all sorts of backgrounds,
Yeah.
different cultures, different lived experiences, bringing their unique insights to the table.
Because technology is not neutral, right?
Not at all.
It reflects the values of the people who create it.
For sure.
And if we want AI that's fair, unbiased, aligned with our hopes for the future, well, we need to bake those values into the technology from the ground up.
It's about being intentional about who's involved, who has a seat at the table and who gets to influence the direction of this powerful technology.
And being critical of the data we use to train these systems, making sure it's representative and doesn't just perpetuate existing biases.
All incredibly important considerations.
These decisions we make today about AI will have consequences for generations to come.
It's a huge responsibility.
So as we wrap up our deep dive into our method, what's the one thing you want listeners to walk away with? What's that spark of inspiration or that thought-provoking question?
Yeah, I think for me, it's the realization that our method isn't just about making AI more efficient.
It's about something bigger.
Yeah, it's about expanding the very possibilities of what AI can be. It's challenging our assumptions about how we build these systems and opening up a whole new world of potential applications.
So we've gotten a glimpse into the future, and it's both exhilarating and a little bit daunting.
That's a great way to put it. It's exciting because of the potential benefits, personalized learning, more effective healthcare, scientific breakthroughs we can't even imagine yet.
But also a little scary because we have to confront these big questions about what it means to be human in a world with these increasingly intelligent machines.
Right. And ultimately, it's a reminder that we need to be thoughtful about how we develop and use this technology, We need to make sure that AI is used to enhance human capabilities, not replace them to solve problems, not create new ones, to empower individuals, not concentrate power in the hands of a select few.
I think that's a perfect note to end on. Thank you so much for joining me on this deep dive into our method and the future of AI.
It's been a pleasure. Thanks for having me.
And thank you to all of our listeners for tuning in. We'll be back soon with another deep dive into the world of cutting-edge research. Until then, keep exploring, keep questioning, and keep imagining the possibilities.